Hi everyone, welcome to the next webinar in 12D's training webinar series. My name is Lisa Stewart and I'm the Marketing and Communications Coordinator at 12D Solutions. 12D's training webinars showcase common industry challenges, taking a close look at industry best practices and how these can be implemented using 12D products. The aim of these webinars is to upskill 12D users and broaden their understanding of the capabilities of 12D products. We run these webinars regularly and record them for posting through our website and on YouTube. The previous webinars from this training series, as well as the webinars from our Industry Solutions series, are all available on our YouTube channels if you missed those. During this presentation, you'll be able to type your questions along the way, as shown on the screen, and we'll answer as many as possible throughout the webinar. At the end, I'll email your questions to the presenter. I think we'll be quite close to time today. It's a pretty action-packed session. Today's webinar will be presented by Peter Tainton, who has over 20 years of experience in various facets of road design. He's been engaged in large projects for several major councils and government road authorities, and has worked closely with our programmers in the implementation of a variety of design features within 12D Model, including the superalignment and design speed tables, construction subgrade detailing, design geometry components, overlays, pad design, interface, and visualization. Today's presentation, Trimesh BIM Objects, is episode 1 in a new series which we'll present over the next couple of months. Peter's going to present for you an overview of Trimesh creation. He'll focus on library and user-defined objects and give you an introduction into future webinar features that will be coming up over the next couple of months. Over to you, Peter.
Thank you, Lisa, and welcome everyone to our first webinar on Trimesh BIM objects within 12D. Today's session is an overview of the features available, so don't be concerned if I don't spend a lot of time on each option, as there will be more detailed webinars to follow. And again, it will be an overview, so not every option will be looked at. I may even just sort of discuss what that option is. So again, under BIM, Trimesh is the 12D menu system. Under Create, we'll just pin those down there. So most of our users here are 12D users, and they're quite up on the fact that we have multiple views available to us, plan views, section views, and perspective views. But for today's session, to make it easier, just on the one screen event here, I'll just work on maximize views. So and just use the tab buttons at the bottom to go between either one. So as I said, like some of the menu system, as you can see for Trimeshes, is quite varied. We're not going to go through all of these today due to the time constraints. So obviously under the Trimesh creation, we can create things from 12D objects. A lot of the times it's the drainage string network that people create the Trimeshes from, but you also can do tins and super tins and so forth here as well. You can read in OBJ files, FBXs. Again, you create from a tin. You can create simple solid shapes like circles, cylinders, and so forth. These refer to the CAD toolbar up the top. As I said, I'm not going through every option, just make you a bit more aware of some of them as we go. There's service chambers and traffic signals, and again, they'll be looked at in a following webinar. But for today, we're just going to look at a couple of simple ones, just to show you what you can achieve just by some small options and thinking outside the box a bit. So Trimeshes from a polygon. So basically, this option will take any polygon that you've drawn. In this case, we're going to look at the creation of a drainage little, just as a small exercise. So the profile is drawn here at 0, that's the cyan string. Obviously, this polygon I'm going to pick can be in any coordinate system that you have. I've just drawn it at 0 just for the purpose. So I can pick that shape, and again, it asks you for a model and a depth, and I can go generate. So we add in the model that we had there, the shape, Trimesh lintel base. Okay, draw a redraw, that's what we've got. So any sort of polygon shape like that, you can do this for lintels like I'm doing now, driveways, house slabs, anything at all. And it will then create that tri-mesh shape for you. The next little option is just a profile along strings. What I'm interested in doing is the lintel shape here is now a solid concrete, but there is actually a void involved inside here as part of the lintel. So I've drawn a profile here that represents that void shape. And I refer to profiles quite a lot during the day. And so this shape is naught origin. It probably can be drawn anywhere, but we want it to be focused about naught. It's then going to be extruded, for want of a word, along this red string. So that's the shape. So I bring up the option under here, shape along strings. So don't underestimate this option. We're only just picking one shape, but it could be a multitude of shapes that you wish to place along a string. So back in our view here, I wish to place that shape along the red string with some levels on it. Just going to put it onto the same model, and I'll go process. So before I redraw, you can see the void shape. This is the tri-mesh that represents the void in the lintel, and the outside concrete one. So we've got now two tri-meshes. So we'll have a look at the union, difference, and intersection. So this is just a couple of tools to get started to break the ice, basically. So we look at our first tri-mesh, our second tri-mesh, and this is going to take one away from the other. So there's other options there, 2 minus 1. You can join tri-meshes together and find the intersection of two tri-meshes. So we're just looking at this process. So if I take off the base, we now have a tri-mesh combined. So very simple little things that can now be a 12DA file, hence why I created it at naught. So that then can be output, and then later on when we get to placing our objects using the more powerful option, we'll be able to array these around our job. So that's how you can create just some simple objects using that union and join option inside 12D. And sometimes the the tri-meshes can look a bit odd, especially if you've read them from somewhere else, and they may actually look a bit different when you look on the screen. They're this sort of option. So if I redraw that, they look like that. But sometimes it just means the faces are pointing in the wrong direction. So there is these global options for flipping things. So in that case, I'll just go back to the way I had it. So these little edit tools to try and debug something that might be wrong with your tri-mesh. There's also a create tri-mesh face normals. So it will actually draw small arrows normal to the face to again give you a bit of an idea of the state of your tri-mesh itself. So again, if we look at some of the more options, like some faces, a lot of times you do get faces that are coming in and you want to try and create a tri-mesh from it. These are coplanar faces, they're touching, you may have exploded something else, you might have created another tri-mesh. So the 3D planar one will attempt to create a tri-mesh out of those faces. Quite a good little option is because in this case it's a head wall. So viewed from the top, this apron area, I'd like to do a texture to, and maybe the top of the walls. But the side bits, they're vertical, so I'd like to just keep them as a color. So I've colored these to that tri-mesh here with a concrete color, and I've ticked on use string color as face color. So when I go create and redraw, it creates a pleasing looking head wall, but not with any textures that might be a little bit hard to see on the sides. So before we break into the main part of the webinar, if we have a look at things like this, so I'm not going to run all these, but we can apply a blend, which is a transparency to tri-meshes. We can contour them. We can create a tin from the bottom surface of tri-meshes. We can explode them, flip them around, find intersections. We can split them up in relation to along a string and a polygon. And so lots of options for our tri-mesh. So investigate some of those when you get some time. So at the moment, we're just going to go into the, again, into the more detailed area. So we're looking at this option here, Trimesh BIM Objects, Create, Edit. Okay, so again, this is a feature that is a create edit option. So it's more of a preview type thing. It allows you to view what you're going to create and edit, and before you go and write off to a file. 12D ship with a variety of shape definitions, I like to call them, and they can be applied to form trimeshes, such as landscape and construction fences with footings, safety fences, guardrails, wire ropes, and so forth, retaining walls, bridge profiles, decking, headstocks, road profiles, service and drainage pits, line marking. And even though you have these ones that are shipped, the beauty of this is you can create your own. So the install list is always being updated. So you may even see some things today that are not in your list, but they will then appear in the actual next release. So again, it's a object create and edit. So we're going to view some of the ones in the standard install, and we can do some changes, and if you want to, and write those off. So the definitions are stored in the standard library file or standard file called 12D Trimesh node link.4D. So I'll repeat that again. So it's 12D Trimesh node link.4D. So that's the file that gets written to with all this information, and it's to be found in your setups area. The file can be copied. You can copy the file to your user or working folder. The format's an XML file, and the file format's relatively simple, and you can actually copy large definition options and rename them and so forth inside a text edit if you wish. You do that sometimes using the XML notepad, but we do have copies and edit options on the panel as well. So when you create or edit option, we're looking to create it at the moment, then we'll go into the apply. So when they're used in 12D, a search is done for that file that I mentioned before in the usual suspects. So we're talking about the setups area, the user area, or the working folder. Now I have a file in different states in all three of those areas, so mine shows up with all three, but depends on what it finds. We're just going to work in our working folder. So again, the definitions are given a name. In this case here, they're the Vertex Segment type, and here the first one on the list is a general fence, and it's called FO8. So that naming basically encompasses these definitions here, the vertex and the segment. So with the naming convention, you can put a / in like that. So when you get the names, you can actually put them into a tree structure, as in general fences, it would be /FO8. So you can have your own. If you don't use that / option, you end up with just the one, like bus shelter here, which has no subdirectories underneath it. So we select our fence type, and to start with, we'll just go preview. It's already, when your option starts, it creates a OpenGL perspective view called preview. So when I go preview, it'll then turn around and show me a preview of the fence that I'm going to work with. Again, it's only a preview, so it's on a models that are temporary models. They get deleted after you finish the panel. What you see on the screen can be user defined. They're under the defaults. So this is a fence I'm looking at. So I'm probably interested in seeing something that looks like a fence. So in other words, I've got spacings at 2.5 meters for the posts, and I just want to see 5 bays. But if it was a road or something like that, you may want to see, maybe 50 meters of the actual definition. So it just depends on what you're looking at, is what these defaults do. So basically, we're looking at, the idea of this was fair to say that it all started with the Vertex Segment definition being placed for a construction fence or a landscape fence or a barrier or something like that. So hence the idea of Vertex Segment. And I tend to still refer to things as fence type things, posts and panels. But the vertex and the shape has gone a long way since that. You're able to utilize profiles, drawn profiles, road profiles, bridge profiles. You can read in 12DA files. So it's a lot more than just a simple fence nowadays. Although it's amazing how intricate some of the construction fences and stuff like that can be, especially with motorway and rail jobs. So it's comprising a vertex. So we'll just look at the vertex part. So in this case here, the vertex would encompass a post and a footing. Okay, so we've got a find button here, which allows you to find the option on the screen. There's only two there, so it's pretty easy to see them. So to start with, the post or the vertex option takes a horizontal shape. Now this horizontal shape is what you would see in plan view. So imagine something drawn at 0, 0, and it's a rectangular shape, or it's a circle, or it's a sphere, or a profile. It might be some odd shape like an I-beam, or a U-shaped bar, something along those lines. It's not a usual general shape like a rectangle or a circle. So whatever that is, it's in plan view, and it's at 0, 0. It can be slightly off from 0, 0, but it's generally in that area. Anything that's got a superstring on it is a shape that's, and when it's created, it uses a superstring rather than a trimesh. The only idea of that is that sometimes the feature you're creating doesn't necessarily have to be a trimesh, which is a little bit heavier on points. So you may just be able to make it a simple superstring, which could be like a wire on the fence, or a pole or something like that. So you've got the choice between either making a trimesh straight away, or making a particular part of the structure a superstring. So when these things go across to IFC, the superstring gets converted to a trimesh anyway. So that's the shapes you have, the choices. Again, a profile, a user-defined profile, and a 12DA file. So a lot of times you get to the stage where you have some fairly, you may have some fairly complicated things like lights and all sorts of stuff that are 12DA files, and you may even read them for somewhere else. And you can place those at 0, 0, write them out to a 12DA file, and then use this apply option later on to array those around your job. So that's the shape. So again, regular shape or a user-defined one. If you'd pick profile off that list, then this button here will allow you to go and pick the shape. So again, I showed you the profile before with that lintel. So that would be something that you would draw, and you'd pick that physical shape, and it would save all the coordinate information for that shape in the file itself. So you don't have to have that shape always in your project. So next thing is, again, I said it's all just an overview of how you do this. So under properties, obviously something to do with the property. So if it's a rectangle, it's going to be width and length. This is a diameter for a pipe, for a circular pole, the color. If it's a 12DA file, where is it? And do you want the shape that you've got, whether it's rectangular or whatever it may be, do you want it to be perpendicular to the final position that you place it, and also rotate at the half angles? So they're the choices that you have. You now then want to take this horizontal shape that you've got and then extrude it, for want of a word, along a pathway. Now that pathway can either be defined as a height, in this case a height for the footing, or you can actually have drawn a string that represents this path of this bent post. So the choices you have is height and path. So again, I've used both here. So when I drew this shape, again, it stores the XY coordinates of that shape in the file. So again, you don't have to have that string or that element always in your project. Again, you just simply give it a height, and there's some offset values as well from the string here, and you give it some names. There are some attributes you can assign to each and all these elements that make up the trimesh definition. And so under there, you just go pick, and you've got a choice. These are all a ever-growing list, just like the trimeshes are. And they're completely user-definable. You can create your own, and we'll have a quick look at that in a moment. But generally, if I was looking at a fence, I could go into fencing, and I could go general, I go continue, and it just gives me a few lists of information about the fence. This is just a small example for you, but it could be quite large and have all sorts of information about the process, and they can all be BIM type attributes that then export out to IFC as tab information. So I could apply this just to each individual one, or I can use this attribute idea when I apply the Trimesh as a global attribute. So they're simply under utilities attributes, global. So we just look at how you edit one quickly. This wasn't part of the actual webinar presentation, but I'll just quickly go through it. So I grabbed that one, which was fence general, and so it shows me the list. I have a choice list of texts and reels. I can put some information on the panel. I can set up a path, whether it's a BIM/fencing attributes, and I can then create a dynamic list. So they're very simple to create. And you can apply them to a string, project attributes, and so forth. So we set a few up, and you can have a look at some of those. So again, that's the segment part. We can save off as many of these types as you want. So we can have the footing and post combined, just the footing on its own, post on its own, depending on what you want to do. The segment part relates to to the basic segments along the string. Similar to the Vertex, it has shapes that you can actually specify. So rectangular shapes, circular, a user-defined profile, a path string, superstrings, and so forth. And so you'll see that all of these wires that I've drawn here, they're all superstrings. Okay, but the chain wire paneling would be a bit too much to try and draw all the segmented chain wire. So we just made it a simple profile. And so that suffices enough to display what that fence is all about without having to do all the intricate parts. So again, it's just a profile. Here's the profile for that, all the coordinates for the shape that I drew at naught. Properties again, same thing. Comes up with property information about that particular thing, diameters and so forth. And these wires are all just a height base from this naught. So you've got height values to position those wires. So again, it's quite handy. So if we go and grab another fence type, as the bicycle-friendly fence, and again, these are all in the standard library. So again, they're the same sort of thing. They're made up of circles along profiles, or simply at a height value. There's a sphere being placed here, which is just a ball at certain points. It utilizes a path in this case instead of a height. So that way you can actually type in coordinates where you want these spheres to be. So you can introduce an X and a Y offset to position those balls or joints. Again, the rails, simply just superstrings that define where those rails are with a height and an offset. These are actually the verticals, and they're again an option that you have a choice of, which says circular vertical. So basically, all it means is it just takes the 16mm diameter pipe you've done. You set a height for it, okay, and a offset, which is from the bottom, so it sits in between these two rails, and then you give it a spacing. So in that case here, if I make that a 0.2 meter spacing, and I go preview again, it now arrays the vertical things at a 200 spacing. So it doesn't matter what that spacing is there, it will always array these and work out how many vertical things that it does need. So again, looking at some of the other ones, we're looking at the barriers. Again, these are just shapes, profiles drawn. The vertex in this case is actually a 12DA file. The actual post is a 12DA file stored in our 12DA library under roads. So we do use quite a lot of those type of ones. And again, they're just arrayed along when you go to place it. We do have all different sorts of options there, but we do also allow you to have a lower level of detail shape. So in that case there, if we go and turn off the posts, we end up with just a block. So look for some of those options when you're placing these later on. that instead of the more detailed type of fence and with nuts and bolts and everything, you can then swap over to a LOD or 100, which is just a shape like that. At the moment, I'm only showing the footing and the showing the panel, and the footing is separate. But when we go to apply this, you can apply both at the same time. So you can swap between the two. Again, electrical, we're talking about conduits and things like that. We can create a conduit shape like that, or if you don't have all this and you're just designing your conduit and you want to do a trench, you can go into the electrical part and just have a simple trench option, which does things like that. So there's just a rectangular shape. That's all that is, nothing else. So if I go into the water reticulation, I've got another trench through there, and so forth. So communications, conduits. These ones are pretty handy because they're all the ones for the drainage and all the services make use of these attributes. So in this case here, it's using the extend trimesh to tin option. So what that allows you to do is to say, yes, when I place this, I want to be able to extend my trimesh, the top of it, to a tin surface. And all you have to do is just say yes, and I specify the name of the trimesh to do it. So when I go and apply this, we can then specify tin, and it will then extend that top of this trimesh up to the tin surface to create trenches for you, of which you can get volumes and so forth. So again, there's lots of different ones here. You can go and have a look at all those as you go. We do have pavement marking. We do even have some roads as well. So I preview the roads. Obviously, for a road highway, 2.5 meters is not a good idea. So if we go to 50 and just write that out and go re-preview again, we end up with a road profile like that. Now, as I said, they're just general profiles drawn at 0, There's a bit more information about these arrays of these lights and so forth, and the line marking. And we'll have a look again at that in another webinar. It's just to give you a feel today of what's there and some general editing. So again, if we simply look at those shapes and also creating some of our own. So if we go into our create new, so we might just say we're doing a fence today, and we go into our Vertex, and I want to turn around and create some posts and footing. Just a little exercise to show you that it's not all smoke and mirrors. And so I just simply have to say, okay, what do I want? A rectangle. I want it to be 0.15 by 0.15. Its color. Let's use some wild colors. And again, I want it to be perpendicular. I go set. And what type is it? It's a height, and the height is 2 meters. So I go preview. So obviously again, we're back to looking at a fence, not a road. So we'll go 2.5 and then again preview. So I start to create our fence. So you drop into here and you say, what do I want? I want a circle. It's a footing, so it's 0.6 diameter. I might pick up a concrete color. And it doesn't matter about rotating a circle. And I want to do a height again, and it's actually minus 0.75 meters. And I go preview. So it creates that. So I drop into the segment part, create new. I'll call this one panel. Again, set. And once you get used to these, it's not too bad. So you just go into the, what am I going to create? I want to create the railings. So railings don't have to be the trimesh. I'm going to use a super string. So I drop into the properties, 0.05, 0.15 deep. Give it a color again. And the height, 0.3. I get a preview. So you get the idea. Start to be able to create those in there. And again, the same process I would have gone through to create the vertical ones. So I go rectangular vertical, and 0.05 is at the width, 0.1 for the posts. for the palings. Give them a color again, slightly different. So the height is just the height of the actual palings themselves. We might want them offset slightly from the rails. We might want a distance off the ground as well. So I go preview. It'll then say, hang on, you need a spacing for this because it's a vertical option. So I put in the spacing there and I go preview. So it creates my fence. Okay, so that's basically what you can do. Won't worry about the other paling. So we write the file out. So once I go finish on the create edit option, and I'm running out of time here, so I've just done half an hour for that part. So again, that's now saved, and you can then come and apply. So remember the preview is only that. You have to, any changes you do, you must write them out. Otherwise, if you finish early, you'll have to go back and do it again. Right, so if I go to my view here, just got some simple things. I've got a tin surface and some strings. I'm just going to quickly go through and apply some of these things and talk about some of the options. So it's created. This one's apply. So it reads the same file before. Any information you fill out here, you can save to a parameter file. Today, in this first section, we're just going to go pick and either just clean the model, or you can go undo if you want to. But we won't worry about the parameter file at the moment. So I pick my string, and again, it's automatically read looking for that 12D Trimesh file. So it's found the areas where it's similar to the create, and we're going to work in our working folder area. We turn around, we pick up the fence we like. We grab a model to put this on. We'll say clean out. You can set attributes. You can also copy attributes from the original string to your Trimesh just by putting in the high level attribute tree, say survey or design. You can we occasionally use a tin surface, but it's here I want to say I'm doing a fence, but I want a 2.5 regular distance now for it, because this string here could be from anywhere, and it could have lots and lots and lots of vertices on it that don't reflect the positions for your posts. And it could also be from an apply menu with multiple points as well. So you're able to say what interval you want, and it just places as and works it out along the string, independent of what the vertices are there to start with. So if I'm looking at my fence, and I just go process, so then it creates my fence. So again, we're looking at the fence type. So again, whatever number of verses on the string, it doesn't really matter. The regular distance will override that for you. Again, when you're looking at that, the level of detail part, again, you can get it to do that. This is where you can actually add the footing in. So in the other one, I couldn't do that because I was only previewing it. Where now I can turn around and put the footing in, and I can get, so I just turn that one off. So now I've actually got just a see-through. It's a solid, but it's just got a blending on it. So now I can actually use that for clash detection and any side distance, that sort of things I may want to do. So we have introduced those for that purpose. So we go back, and again, I'm just picking this. I'm not writing out the file yet. So I go to here and I grab our fence. That was a pretty cool one, and process that, and then creates the fence that we created before. So it takes into account any bends and so forth, and tries to arrange the spacing, whatever I specified here as well. So when it comes to barriers, and we do have a webinar in a little bit more depth on the creation of barriers in the construction world. We're just going to pick safety barriers and just do the guardrail one. So in the safety barriers, I can specify a tin surface for this one. So I want my W-beam and my post. We're then going to create that for you. So the string that you draw, you only need the string that relates to the barrier itself. You don't have to do the flares and stuff like that. They're on either end, because they're just simply added here. So if I look at the flare approach, and I go start and process that, it'll then turn around and create the flare for me. Okay, so it needs the tin surface, so that it can work out where these posts are supposed to sit in relation to the ground, the road surface, and this sort of mechanism as well. And again, as we said before, if that's too much detail, you can go to the LOD 100 part as well there. So for the end departure, I don't have the flare, I just have the end only. We put that on there in process, and it will then do the end part for you. So we're always looking at expanding all these barriers and stuff like that, and limiting the amount of effort that you have to do at the end there. So now if I grab safety barriers and say the flexi one, again, turn that on. So as you pick each one of these, a new one, this gets refreshed. So you have to make sure you go and select what you want. So again, it has an approach part to it. So all the diminishing posts have been created for you, and the anchor block at the end. Again, that's just a 12DA file, and brings it in every time and positions it where it's supposed to be. So you're looking at those sort of things, barriers and fences, and so again, I do apologise for the speed, but we're just giving an overview at this stage. So we're going to pick this string here, which would probably represent a service. So it's a metre or so below the ground, and we want to apply a trench to that. So we go down to our communication one, grab a conduit, and we say I want a trench. So without the tin specified, and I might make this 1 metre instead of 2.5, just to get a bit more graduations along the trench. It creates a trench, but it hasn't extended to the tin surface. So remember when I said before, I showed you in the created part that we had that attribute that said extend to tin. So that has been set for this particular shape, but I didn't specify a tin here. So I'm able to specify the tin now, and then go process, and then updates the tin surface. So the idea is that it's better to possibly do it here, so you have a varied tin specified rather than specifying the tin inside the definition itself. The same idea with the services. Again, we pick our drainage network, can be water, sewer, or stormwater, and I go and grab the drainage one, and I grab trench. It's also set to extend the backfill up to the tin surface. So I turn on trench and go process. So if I have a look at some of this, that's the actual trenching for you, done. And if I go to my section view, I do a redraw here for you. Okay, it's smart enough to know that what the diameter of the pipe is. Where the other one was a trench with, could be any size. This is for a proper network. So it will actually, there are 12DA files done for the trenching around each diameter pipe. And the top one is called backfill. So if we have a look at this, so we're talking about the foundation zone, then we've got a overlay zone, and we finally at the top got backfill. So backfill is the only one that gets extended up to the surface. So that's how we work with all the drainage trenching. So for things like this, if we go and pick a wall, this would be again a string below the ground. So we go and grab again the retaining wall, grab concrete, toe out, and we go process. So again, this one here hasn't extended to the tin surface because I didn't bed anything in the actual definition, but I can do it here. I can go into here and I can go Trimesh extend to tin, continue. I want to extend the top of it. The mask is called wall. Okay, I'm going to set some information about the BIM attribute path for that particular thing. And I can go process, and then extends up to the tin surface. So that idea of being able to extend these trimeshes up to the tin just allows you that bit of extra capability of being able to do volumes and things like that later on. I'll look at the clock, and we're running out of time. So basically, we're looking at other options in here for pavement marking. So go to line marking and say I want a edge string. We can just clear those attributes. So we'll put in the same model, it's fine. So it starts doing edge strings and things like that. So we pick another string, which might be a continuity line process. So it actually drapes the physical shape onto the tin, and before it creates the trimesh. So it will follow the crossfall of your road or any other option. So if you pick a center line like that and select double two-way, it will actually do both of those in relation to crossfall. And again, you can picking things like this. So in our list, we have some pavement marking for pedestrian crossings. We don't need one for that, and we go process. Also things like symbols, pavement marking, arrows, that sort of stuff. So we go into here, we've got pavement marking, symbols, might want a bike lane arrow, and I want every 10 meters. Process, it then creates that for you. So that's the idea. So more likely, sorry about running out of time, but more than likely just setting things like this in a nice little demo, but it does also apply to your design roads. So again, here we've got a design, but the fences and the barriers and all that sort of stuff that we need are being created afterwards. So in this case, we've actually specified a parameter file. So I can just read these in, and I can just go motorway fence, read, and it stores all the information, and I can just go process now. So we're going to speed this up a little bit for you. So basically, it's now producing that boundary fence, which is a string draped onto the existing ground, and it's now producing those typical type fences that you see with the chain wire and the barbed wire at the top. So we go and grab another one. So this might be a barrier here, a concrete barrier and drain that's being part of your apply menu design. So that there's a string on top of this wall that represents the board or the gork board, they like to call it, or some sort of option that you want to place on top of that barrier. So it's out of the apply menu. So again, it's got lots and lots of versions on it. So if I go and grab the fence, read that, and then process, it'll then create that board on top of that string, but not at all the vertices that your apply menu would have created. So again, there could be another string here, a magenta string that's part of your design, just like your lane lines, and you've specified where that stops and starts. So, and I want to do a barrier plus the board on top. So again, I process that. It then goes and creates that barrier for you. So different combinations of how you can use these. Again, there might be another string here that is for the guardrail that we showed before. So if I read that in, we do a lot more in following webinars on guardrails and barriers and things like that. Again, these strings are out of your apply menu. We can turn around and say we want a motorway lights. So we've got a string here that represents where we want our lights. They're every 50 meters apart. We go process, and it creates all lights for me. So again, the same idea for the line marking. So I'm looking at the full line marking here. So it remembers all those strings and so forth and runs that for me. So at the moment, it's not a mapping type thing. You do have to come through here and run this, but we are investigating different ways of applying these particular shapes. So again, we're looking at lane lines. And I'm doing nothing different here than what I did before. It's just I saved it to a parameter file. So I go process, creates that. And also those pavement markings we did before. So if I process that one, it's actually put the pavement markings on there for me. But again, these attributes are very handy because as I place this, I can also then go and bring up the pavement marking directional arrow attributes. And that allows me to specify how far away from that string I want this. And obviously it drapes because we've specified a tin here. So being able to run these things and on design strings that have lots of vertices on them and it can be quite complicated and so forth. So you can get them out of your design with the advent of layers inside your MTF file. You can put these on a different layer, hence onto a different model in your design, and then run this afterwards. So again, just to recap, I said that you use the preview value, the create editor to look at your shapes, create them, define them, and then that's where you save it to the file. And then the apply part then allows you to be a bit more creative in where you apply, how often you want them, and so forth. And again, we'll be doing some webinars on the services and trenches and all that sort of stuff, and pits. But as I said, today is just an overview on how this works. Surprisingly enough, you can get a fair way with it just with following the library ones without having to know how to create them. You just use the ones that are in the library. The overall idea of this, being able to create shapes and draw profiles, led me to think that we should be able to then create shapes and profiles that reflect roads and sort of major motorways, bridges, and those sorts of things. And can we create a shape, a general concept idea of what the road would be like? In that case here, we had a bit of a quick look before at a bridge and a motorway, but I've created some strings in here down my road centerline. All that's in that MTF that I used was a insert string for the motorway, a bridge, and the continuation of the motorway. So I go and pick that string, and I drop down. I say, okay, I want to grab a major road, and I'm going to do a 8-lane median, small median. I don't need those attributes anymore. There's no tin involved in this particular job yet, and I want the sections to be, or the samples to be, roughly 10 meters apart, and I want to create that segment type. So I go process, oops, wrong model, motorway. Right, so what have I done? Nope, haven't added it on. So I added my motorway, and there's my motorway there. Okay, so you can see it's quite a long way. It's the same one I showed before, but it's along a real world string now, and sampled every 10 meters along the string. So I don't want to clear that out. I'll just pick the other side of the road, the other side of the bridge, process that again. It then creates the other part of the bridge, or the other part of the freeway. It's only the fixed part. It's just an idea, a concept, what it would look like. You can apply it to different alignment strings and so forth. So there's no interface at this stage. We will look at future webinars showing you how to do that. So then go and pick the string that represents the bridge. It doesn't need any interval because it's just got some vertices along here that represent where the pylons and headstocks are. And I go and grab the one in the library. I grab 8-lane bridge. So I can say the headstocks are the intermediate points. I want a headstock at the start and end, and I want to be able to do the girder profile for the entire length of that string, and I get a process. So it'll turn around and create that for you. So basically, it's straight out of the library. Define profile for your. As I said, it's a concept idea. It hasn't done all the details for what happens on a normal road design, but it also did it in 3 minutes. So the idea is you can utilize this. If you do specify a tin surface when you do the bridge, it will actually trim off these pylons and also this spillway into the actual tin surface itself. So basically, we're looking at creating something like that straight out of those profiles. And everyone's done a plot, everyone's done a section of a road, and that's all you basically have to draw is the shape that represents the pavement, the little line marking shapes, and whatever that barrier looks like with the actual bridge. So that's where I feel that this sort of stuff will be going. The fact you can create your own shapes and so forth. It should be easy enough to sort of expand your library as well. Just to finish off on that sort of stuff, this is where I like this stuff to sort of go. There's also an option under here to on normal designs is to create a tin from the bottom of a trimesh. So in this case here, this road has a pavement defined in the actual profile that I have as a 12DA. So it actually gets a name called pavement. So this option here, you can use this on any pavement road, not just these types. But if you go and pick the tin from Trimesh, it actually creates a tin surface and you specify what Trimeshes to use. So in this case here, I picked this button and it comes up and says, okay, the Trimesh is on a model called TM Motorway. And I want to get the bottom surface of everything that's called pavement. So it will go and find the bottom facing down surface of all that Trimesh and create a tin for you. So basically when that runs, you end up with a motorway tin, subgrade tin, which is that one. And if I minus off the Trimesh, you end up with a tin surface. So that's the idea of these sorts of things, being able to create these tins. So once you do this and you've got the interface, you end up with a tin you can get volumes out of and so forth. That gives you a bit of an idea of a scope and what's available there. And as I said before, it's even if you just use what's out of the library and go straight to the apply part, it's fairly straightforward. And the fact that you just simply, again, you simply just pick what you want, a model, how regular interval you want, and tick what you want here. So generally, most times you just be using the all option, which is the entire string, but you can then start to work on each individual vertex and segment along the string if you want. As I said, today is just an overview of what it was, not a training exercise. And my attempt was just to give you insight into what's available there. So hopefully you can attend some of the more detailed webinars to follow. So I just like to thank you all for attending, and back to you, Lisa.
Thanks for that, Peter. The recording of today's webinar will be available in coming days through our website and our YouTube channel. Keep an eye on our emails and social media for details of our future webinars. And in other exciting news, the 12D Synergy team is hosting a roadshow across Australia this November. It's all about how you can take your business mobile with 12D Synergy versions 4.3 and 5. You'll see 12D Synergy's new features in action, including a new offline data mode, CAD plotting, cloud, web, and 12D Synergy mobile. You can also meet the 12D Synergy team and network with other 12D users. The roadshow will be travelling to Melbourne, Sydney, Brisbane, Adelaide, and Perth. Registrations will be opening soon. The event is completely free, but spaces are limited, so make sure you grab your ticket as soon as registrations open. And if you need to contact us in the meantime, our details are on the screen now. That concludes our presentation for today. Thank you all for attending. We'll get answers to your questions emailed through by Peter soon. I can see lots of great questions that have trickled in as we approach the hour, and we hope to see you at future webinars.